This is Hallicrafters Rehabs. Welcome back. So, funny thing, I was going through my chips and I found 2 weeks ago some videos that I did not post relating to the alignment of the set. So, we're going to go back and we're going to post those as well after this little intro. And at the time, the set had not been aligned and the case was off. So, other than that, it's pretty much the same as then. Finished up, but ready for alignment. I have it on its side right now. This is Saturday morning. And it's working every bit as good as it did before I started. There are a few things I have to address. But it was a little bit more sensitive than the Mark I before, and it's got every bit of that right now. We're listening to Japan radio on 11925, and we're getting some good atmospheric conditions with A index in the 90s right now, so that's good. Some sunspots and a little bit of ionosphere for bouncing things. So just to give you an idea of where it stands right now, and a couple of things I noticed. See if that's in this. It's barely. It's hard to see it. Both of these two trimmers are got some intermittency to it. It may just be some debris behind it, or I may have to replace it. So that's something to address. And the notch filter, as you can tell, we can't do much with that right now because I can't adjust it. After reconditioning that's a little bit too tight, but we'll have that to do. But the next thing we'll do is we'll put it on the spectrum analyzer. You can't see that. Let's see, lower. We'll put it on the spectrum analyzer and compare how the one thing I have noticed about it is that it seemed to be developing some images around 50 kilohertz above and below high frequency, high power signals, or something like that, and those are gone. So it's probably related to the repairs made in the mixer box for the 50 kilohertz IF. So that's been cured. So we'll put it compare the visual images on the as-built visual images of the IF versus the as-found or as-left before we did the refurbishing. So that's next. All right, so let's see if I can get this clearly in there. No, I can't. I had it clear a minute ago and then now no. Okay. So I did not have, when I did the alignment earlier on the set, it was the traditional non-visual alignment. I went through the whole procedure in this, but on the Mark I have this curve, which is pretty close to what I have for the Mark 1B. It says 3dB down bandwidth 1000 hertz, and it's at 50.5 essentially uh, as a frequency, as a IF frequency. When setting up for visual alignment, you want the signal generator connected to test point A is right here. I always put in a little gray test point. This is gray insulated wire, but at the end it's open, so for a good contact. And so I'm injecting the sweep generator in right at this point, which is pin 1 of T2. Well, on the schematic, that's test point A. And then test point B is right here in the midst of actually the AVC circuit. It's actually between both diodes of the 6BJ7 tube right there. And this is test point B, and that's the pickup for the spectrum analyzer, and then they're both grounded. So we're looking at the sweep right now of the 50.5 kilohertz IF. It is, you take the oscillator tube out so that you're only getting a signal through the 50.5 actually mixer box and to the other side of the 50.5 second IF coil arrangement. It's actually in a coil arrangement as opposed to a true transformer. So take some time to find, without a tracking generator, you have to manually find the point where you get the best response on the in terms of sweep of the spectrum analyzer and sweep of the signal generator, which I have below the shot here. And we're looking at that's the frequency, this is 50.5. And so we can do an adjustment now. It probably doesn't need it because I think the traditional alignment did a great job on it. It's really quite excellent, but I think it's a good idea to check. So you have, I've already got a separate video of the traditional alignment for this set, so we don't need to go through that again. But I'm looking at the 4 IF 50.5 IF transformers, and let me go get a schematic. I had to check the schematic because I wanted to be sure I was referring to T3, T4, T5, and T6. They are actually, each one is a half transformer coil. They're in separate cans. Now I'm adjusting T3 right now, and let's see what we get. I've not actually got it inserted, but I can't. Oh, this is the wrong tool. That's a good one. Let me just go, I'm going to do a quarter turn up clockwise. And there was no difference, so what I want to do is zero in here. And we'll check 3. There we go. Just go ahead and set this display up. All right, let's see if we have any effect. 4. T5 and T6. So sweeping really doesn't have any effect. Alright, so we're going to go straight to a simple 50.5 kilohertz non-swept. All right. Not happy. I don't know. You're going to have to work with it for a while. Okay. After lots of time, it's sweeping and not sweeping and finding settings, spectrum analyzer, and so forth. Basically, the response curve for the 50 kilohertz is very broad, just like this. So when you're sweeping, you're really not getting much information. You're looking for very, very small differences from one frequency to another. So it's purely a maximum amplitude result, which is over here on this VOM, or analog VOM. Still can't get rid of those, I'll tell you. They're good, aren't they? Nothing like the needle. And you're just looking for the best output here, which will be reflected here, and this is not in the sweep mode. So it's not particularly interesting to look at this curve at the 50 kilohertz second IF. But that's what it looks like. And I'll take a picture of that, and then we'll go on to the 1650. All right, after more time, it's actually good to have both the spectrum analyzer and this meter. This meter really does help you find the passband. So the instructions say to rock the signal generator back and forth until you get the center of the passband. And then you can also see it on here. It's very difficult to take a picture, because when I take a picture, for some reason it gets unstable in this configuration. But there's about a 1 kilohertz 3 dB down 1 kilohertz bandwidth there, and it resonates best. You can't see the signal generator, but 1649.7 400, 16.497 400, and that's a little better resolution than the spectrum analyzer, which just says 16497. So just this is what it would look like sweeping. Okay, I am not sweeping. Okay, let's somehow mash the function button without knowing. Okay, that changed everything. So we'll have to stop. The instructions say to slowly rock the signal generator back and forth until you get a maximum response. Actually, right here I'm looking at the AVC circuit in the same test point B with this meter, and this seems to be the easiest way to look at the maximum peak signal. You will also see it on this curve go back and forth. This is not swept. This is just a this is just picking up right now a peak of 1649,700, which is in the signal generator is 1649,600 hertz. So it's 1.64976 is on the signal generator, and the response, that's a little finer frequency division than the signal generator, the spectrum analyzer can see. So it's just pure signal at this point, and you're looking for the maximum. Now it says adjust the 16T9 top until output, we have output, okay, and adjust for maximum output by adjusting the signal generator frequency, crystal activity top of S, and 1650s IFs, top and bottom, T1 and T2. Note that the signal suddenly disappears when the crystal activity slug is turned into the coil and gradually drops in level when the slug is backed out. Set the crystal activity adjustment top of slug 9 for half output on the gentle slope. And the point behind that is it gets too unstable when it's close to cutoff, and you won't have a radio that works through all the bands. And I have to move the camera to do this. So I have my tool here on the top of T9, and we're just going to see what happens here by turning it in. Actually, there we go. And we're beginning to see a little bit of increase here. Not much, though. Somehow, I should be seeing something happen, and I'm not. So we have to investigate that one. So that was the end of the video that I had shot. Here is the plot of the 50.5 kilohertz, very blown up at the peak, and as you can see, it's really not a peak, but a double peak with a little thing in the middle. And so what we see then is a center frequency of 50.5 kilohertz there, and a distance between the two peaks of 4.8 kilohertz. And this is what you'll see at either the upper sideband or the lower sideband, as you see in the instructions where figure 12 is in the receiver. So that's what it looks like at that IF. Now we're looking at the plot of the 50 kilohertz IFs, and one thing that I did mention is that once you've got the T9 in the sweet spot, so to speak, where I like to run my radios at as close to as possible to the peak without there being any loss of oscillation of T9 on any of the bands in any place. So when I get to the peak where I think it'll be at that point, I'll just sweep all the bands just to make sure I don't have it drop out anywhere from that particular setting of T9. And at the same time, I'm also adjusting the two 1650 IF cans top and bottom for the maximum output on that little VOM meter. So when you're doing T9, you first find the place for T9 to be, and then you adjust those other 4 slugs in the top and bottom of the two 1650 IFs. So that is all I have for this particular video on alignment. And certainly if you have questions about aligning an SX-100, you can leave a comment and I'll be happy to respond. This is how I just should also say that I really appreciate the new subscribers, and I thank you so much for watching. I'm hoping this is useful for anyone who loves these radios as much as I do. Now we're looking at the plot of the 1650 kilohertz IFs, and one thing that I didn't mention is that once you've got the T9 in the sweet spot, so to speak, where I like to run my radios at as close to as possible to the peak without there being any loss of oscillation of T9 on any of the bands in any place. So when I get to the peak where I think it'll be at that point, I'll just sweep all the bands just to make sure I don't have it drop out anywhere from that particular setting of T9. And at the same time, I'm also adjusting the two 1650 IF cans top and bottom for the maximum output on that little VOM meter. So when you're doing T9, you first find the place for T9 to be, and then you adjust those other 4 slugs in the top and bottom of the two 1650 IFs. So that is all I have for this particular video on alignment. And certainly if you have questions about aligning an SX-100, you can leave a comment and I'll be happy to respond. This is how I just should also say that I really appreciate the new subscribers, and I thank you so much for watching. I'm hoping this is useful for anyone who loves these radios as much as I do.